Let's try to understand what's going on with a zero exponent by looking at powers of 10. So 10 squared is familiar, it's 100. 10 cubed is 1,000. 10 to the fourth is 10,000. We're adding a zero every time we increase the exponent. So if we decrease the exponent, we're taking away a zero. And by the time you get down to 10 to the power 0, you should just have 1 on its own. And we can repeat this with other bases and find the exact same thing. So 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16. We're doubling every time we add 1 to the exponent, and we're dividing by 2 if we subtract 1 from the exponent. So 2 to the power 1 is 2, 2 to the power 0 is 1. So regardless of the base, when you raise it to an exponent of 0, you get 1. So 5 to the power 0 is 1, 723 to the power 0 is 1. You've got to still be careful with order of operation, though. Negative 4 to the power 0, if you don't have a bracket around negative 4, it's the negative number, so it's negative 1. The only exception is 0 to the power 0. That's undefined, or sometimes referred to as indeterminate. The number system that we're most familiar with is the decimal number system, which basically just means base 10. So a number like 2,345 can be interpreted in terms of multiples of powers of 10. So 5, working from right to left, is the units digit, 4 is the tens digit, 3 is the hundreds digit, and 2 is the thousands digit. So we can write 2,345 as a sum of multiples of powers of 10. So 2 times 10 to the power 3, which is 2,000, plus 3 times 10 to the power 2, which is 300, plus 4 times 10 to the power of 1, which is 40, plus 5 times 10 to the power of 0, or 5. So we get 2,345. Now, we only use base 10 because we happen to have 10 fingers. Other things like computers use different bases like binary. Binary is base 2. And just as with base 10, you have to have 10 digits, 0 through 9. With base 2, you only have 2 digits, which is 1 and 0. So how do you make a number with just 1 and 0? Well, again, the position represents a multiple of powers of 2. So working from right to left, the 1 on the far right there represents the units digit, or 2 to the power 0. The next 1 is 2 to the power 1, or the 2's digit. The 0 is the 2 to the power 2, or 4's digit. And the 1 on the furthest left is the 2 to the power 3, or 8's digit. So this number is 1 times 2 to the power 3, plus 0 times, that should be 2, not 10, to the power of 2, plus 1 times 2 to the power of 1, plus 1 times 2 to the power of 0. So what does this all actually correspond to in our more familiar decimal notation? Well, 1 times 2 to the power of 3 is just 8, plus 0 plus 1 times 2, plus 1 times 1. So 8 plus 2 plus 1, which is 11. And there are really no limit to the types of bases you can have. Octal, which is base 8, is also used in computers. If you've done any programming on the web, you may have come across hexadecimal, which is base 16. So you need 16 digits, 0 through 9, and usually you add A through F to get the 16. And really any number of base is possible.